in which what we're going to do is we're going to treat both objects as a single system. The first step I take in that is I want to try and visualize, instead of these as separate objects, I want to try and visualize them as one single object. And I do that by drawing a dotted line around both of them so that it's easy for me to kind of visualize them as moving together as one. I mean, we know they move together as one. We saw that in the earlier segment of the video. And this dotted line helps me think of them as like one object. Of course, I want to draw the forces that are acting on this object. So I'm going to draw force gravity of M1 and force gravity of M2. Notice I'm not drawing force tension. And the reason I'm not drawing that is because force tension is now internal to the system. It's not an external force on the system. For example, when we draw the free body diagram of just M2, M2 is comprised of lots of little molecules and atoms that are being held together through atomic forces. But I don't draw all those forces that work together to hold M2 together when I draw the free body diagram for it. I only draw the forces that are outside of M2. Similarly here, we're just drawing the forces that are outside of our system. And force tension is inside the system, so we wouldn't draw it when we're drawing our forces that are acting on the system. Just like before, we want to bend our axis of acceleration because our system is accelerating like this. It's on the left side of the pulley, our system's accelerating up, and on the right side of the pulley, our system's accelerating down. And now that it's all one system, we can really just say that that's the way the system is accelerating. So just like before, what we're going to say is that any forces on the left of the pulley that are going upwards are positive, and that are pointing downwards would be negative. So this force gravity of M1 would be a negative force. And on the other side of the pulley, any forces that point down are positive, any forces that point up are negative, so force gravity of M2 would be positive. And that makes sense. If we want this axis to point in the direction of acceleration, then it must point in the direction of net force. And we know that the force gravity of M2 is larger than force gravity of M1, so the net force points this direction, which means it's going to accelerate that direction. So the net force and the acceleration are pointing the same direction as we know. As usual, the next thing we want to do is we want to write out our net force equation, except now we're writing out the net force of the system. So this is the forces added up that are acting on the system, and that's both of these forces that we've illustrated here. So we've got plus force gravity M2 minus force gravity M1. And that makes sense because force gravity M2 is helping it to accelerate this way, whereas force gravity M1 is opposing that acceleration. And then we want to set that equal to mass of the system times acceleration. Well, it's not just M1 that's accelerating, and it's not just M2 that's accelerating. It's both masses that are accelerating. So we set that equal to M1 plus M2 times acceleration. We can divide our M1 plus M2 over, and again, voila, we get the exact same equation for acceleration. So that's a second method that you can use to find the acceleration of a two-body system. Treat both objects as a single system. Now there's one more thing that we need to talk about here, and that is how to find force tension. Oh, I should mention this. One thing that I really like about this method and this final equation is that it really shows us that up here we've got the net force on the system, this helping it accelerate, this trying to oppose the acceleration, and that's divided by the mass of the system. Both these things are accelerating. And so the net force divided by the mass is going to equal acceleration. All right, like I was saying, I also want to show you how we go about finding force tension. Notice that force tension is nowhere to be found here. And in our previous problem, when we solved for acceleration, force tension was, we substituted it out, so it kind of disappeared when we solved for acceleration. So the way we're going to solve for force tension is we need to just focus on a single object. So for example, I'll focus on M2 in this situation. But we still need to be cognizant or aware of our axis of acceleration when we do that. And what that means is force gravity of M2 is still positive and force tension is still negative, because on this side of our pulley, things are accelerating downwards, which means we'll assume downwards is the positive direction and upwards is the negative direction. So when I write out my net force for M2, it's going to be plus force gravity minus force tension equals M2 times acceleration. And I can solve for my force tension by adding it to the other side and subtracting M2A to this side, and there we go, we've got our force tension. And we know that we're probably going to be given the value of M2, so we can multiply that by the gravitational field strength to find force gravity, given M2. Over here we found acceleration, so we've got acceleration. So by plugging in those values, we can solve for our force tension. Again, I think kind of the keys to what we talked about is when we want to find acceleration, we want to treat both objects as one system. On the other hand, when we want to find force tension, we need to focus on a single object because, well, we need force tension in our net force equation in order to be able to solve for it. All right. I hope that's helpful.